Hi there, my name is Will Valida. I'm a software engineer and Microsoft Data Platform MVP based in Auckland, New Zealand, and in this video we're going to be talking about data modeling in Azure Cosmos DB. So in our last video we discussed what Azure Cosmos DB is, what type of applications we might use Cosmos DB for, and we also went through a quick demonstration on how we can set up a Cosmos DB account via the Azure portal. So now we're ready to dive into our list of topics that we need to understand when designing applications for Cosmos DB. In this video, we'll be tackling our first topic, modeling the data that we're actually going to be storing inside Cosmos DB for our applications. When we're modeling our data for our applications that will use Cosmos DB, we might ask ourselves the following questions. Why should we care about data modeling in Cosmos DB when it's a schema-free data store? How is data modeling different in Cosmos DB compared to what data modeling might be when we're developing applications that use relational data stores? And how do we express relationships within our data store, bearing in mind that Cosmos DB is non-relational? So to answer these questions, we'll use an example of an online bookstore. So in this hypothetical application, we will store information about books, the authors of those books, and in this example we could also hold information on reviews of those books that users or customers will make on those books themselves. So let's take a look at how we might model this using a relational database. With relational data stores, we would usually normalize our data and break each entity into discrete components. So here we've got a book entity with author, book name, description, genre. We've also got a review entity and also an author entity. Books can have an author, they can have multiple authors, books can have multiple reviews, etc., etc. Essentially, the idea behind normalization is to avoid storing redundant data and refer to other data. So, for example, if we wanted to retrieve all the books that were written by a particular author, we would write a query something like this. Essentially, we would get a book for an associated author along with the ratings of the books that they've written, and we need to use joins to denormalize the data back to us whenever we want to see this type of information. And alternatively, updating all this information would require us to perform write operations across different individual tables. Now, you might be thinking while watching this, well, this approach has worked for us in the past, why wouldn't we do this in Cosmos DB? It makes sense to keep discrete entities in separate tables. And since you've said, Will, that Cosmos DB doesn't care about document schema, why should this be any different in Azure Cosmos DB? Well, there are a couple of problems with having separate tables, or containers as they're known in Cosmos DB. Right out of the bat, Cosmos DB doesn't have support for joins across containers. So you won't be able to join data sitting in one container to data that's sitting in another. That's not possible. Taking this approach also has cost repercussions, not just technical ones. So we haven't talked about throughput yet, which I'll do in a later video. But depending on how you provision throughput on your databases and collections in Cosmos DB, having a bunch of different collections that store different kinds of data that have different amounts of traffic on them, that might not be the most efficient approach to take. And finally, performing operations across these different collections will be kind of messy. You may have to perform SQL-like joins in your data in memory, which may require multiple reads and multiple trips to the database. Then trying to update your data all over the place means you have to perform multiple writes all over the place. And it's just a little bit messy. So with all this in mind, you might be scratching your head thinking, well, how do we actually model our data in Cosmos DB? And luckily, we have a few options at our disposal. We can use embedding in our documents. We can reference data in some documents that indeed reference to data in other documents. We can use a bit of both using a hybrid approach, or we can be really ambitious by storing different document types within the same container. Let's take a look at embedding first. With embedding, we treat entities in our models as self-contained items within our documents. So here I have a book with an author entity embedded inside our book document. Now all our information related to this book is now embedded in a single document. So querying for this book doesn't require any elaborate joins to multiple tables. We have one document, one collection, one request. Getting data related to this book is a single read operation. Updating it is also a single write operation. This is nice and simple. The general guidelines for using embedding are fairly straightforward. If we have contained relationships between our entities, if we have one-to-few relationship between entities, if the data that we embed in our documents changes infrequently, if the embedded data itself doesn't grow without bound, so essentially there's a finite amount of embedded data that we would actually embed in our documents, and if the embedded data is queried frequently together, these are really good. This is really good criteria for when we can use embedding within our documents. Now let's take a look at referencing. Bear in mind that despite being non-relational, we will still have relationships in our data that we store inside Cosmos DB. This is inevitable. Now, if we need complex relationships, it would be better just to stick to relational data stores. But if you have some simple relationships within your data, we can use referencing. Let's take the following example. Now, some authors in our application might publish more books than others, and it may be impractical to store all of their books, in a single document. So what we could do, we could add a reference to the books that they've written into another document. This approach is great if we have arrays in our data that are unbounded, or in other words, can grow to an unlimited size. We can even avoid having the book array in our author document here entirely by actually adding a reference to the author within our book document. So this example here is just one approach. An alternative approach could be that instead of having a book array inside my author document, I could reference the author ID or author name in the book document. So the great thing about referencing is that we have a couple of options at our disposal to really optimize our data models. So here are the guidelines we should follow if we want to use referencing in our data. If we have one-to-many relationships or many-to-many relationships in our data, we can benefit from referencing, particularly when it comes to heavy-duty write operations. If that related data changes frequently, then referencing the frequently changing data would be a lot better than embedding the data within our documents. Also, if our reference data grows without bound, that means the reference data has an unlimited size, then referencing is the better approach to take over embedding this data within the same document. Of course, thanks to the schema-agnostic nature of Cosmos DB, we aren't limited to choosing one approach. We can actually use a hybrid of both embedding and referencing depending on the nature of our data. So take the following example. Here we've got a book document that embeds data that's storing information about our cover image of a book, and then uses referencing to reference the authors of our book. Using this approach, we can make a single write operation to update information about our books without making updates to our authors. And if we need to make an update to our authors, we can make a single write operation on our author document without having to change our book document. With this approach, we're referencing our author ID within our book document. Now, if we wanted to be really adventurous, we could actually insert both of these documents within the same container. Now, I suspect that you think that I might be being a little bit too ambitious here, but let's take the following example. Here we have books and reviews within the same container. We have a book document here at the top, followed by two review documents that have a reference to the book ID as part of their schema. Now, what's important to note here is that we have a property called type that differentiates between our documents. So our book documents will be of type book, and our review documents will have a type of review. Using this method, we can query the same container and then perform inner joins on our documents if we wanted to see all the reviews in a particular book. We would take this approach when we have multiple related documents that sit within the same partition inside our collection, and I'll talk about partitioning in my next video. So as you can see, even though we've stepped away from our relational thinking into a whole new world, I hope you understand that being mindful of your data models and how you model your data is still vital in Cosmos DB. And now, having watched this, you have a few methods up your sleeve to ensure that your data model is optimized for your applications. Now that we understand the importance of data modeling in Azure Cosmos DB, it's now time to discuss how partitioning works. This is a vital concept to learn, as understanding partitioning will really help you build scalable applications, so make sure you stick around for that video. Anyway, thanks for listening. As always, if you have any questions, feel free to comment in the comment section below, or feel free to ask me either on Twitter or LinkedIn. See you next time.